Hey there, myself Krishaitukam, very warm welcome to all and very warm welcome to the artificial AI series. And in the series, we actually focus on their like mathematical part. And today we actually focus on the Jacobian matrix. This is an important one. And I just moved toward the little bit depth of the mathematical topics. Because of that, we need to understand the idea behind it. So I think like Jacobian matrix is important, play an important and crucial role when you actually want to just design a machine learning concept and all this particular stuff. Okay, so that's an important part. Okay, so we need to discuss. Okay, first, so let's come to the understand Jacobian matrix. When we actually talking about Jacobian matrix, so actually matrix is all about like it contains all the dimensions data, and it helps us to easy for multiplication and add subtraction and for large high dimensional datas. Okay, if we do a particular thing at manually, I think like 1 plus 1, then it's take a time, but for reducing computational cost, we actually use metrics to process the high dimensional data. Okay, and that the basic thing of the metrics work in that particular neural network and deep learning and overall artificial intelligence. Okay, so Jacobian matrix. Let's come to Jacobian matrix. Jacobian matrix is we can say the first order derivatives of all the particular function of input and output. So how much we basically, if I want to just Jacobian, if I want to explain this particular one, and I give you the three magic word to understand this particular concept: sensitivity, direction, and transformation. So how it's work? Jacobian matrix is all about sensitivity. It's help us to know how much the input and output sensitive to each other. So let's suppose in their classroom, let's suppose a particular classroom, and you want to know that how much the each student are helpful to each other. Then what you can do? You apply lots of trick to just test this particular student. So that's similar in their particular entire in that artificial intelligence in the mathematics. So when you actually want to just know that how much the each data points in data structure, in data types, data sets, how the datas are sensitive to each other. Okay, how input and output especially are sensitive to each other, then the main then we can use the Jacobian matrix to do particular stuff. So in that particular one, we not actually deal with the manual data, but here we take the function. So let's suppose function of a function of input and function of output. If we just want to know the sensitivity of each other, we need to find out partial derivative. So the first order partial derivative side, that we first derivative of this particular all of them, then help us to know that how much these are sensitive to each other. So if we just do this particular thing, like let's suppose this particular one, like partial derivatives. So we need to find out the partial derivative. This, let's suppose fm is output and xn is, so we need to take this particular partial derivatives of this one, and this particular we get like the all the possible gradient. As you know, gradient is all about like shows that how much the weight on biases we need to increase to just adjust the model performance to loss, minimize the loss function. So this all the particular respectively are according to their arranged in such way, all the particular input and output, how much they are sensitive to each other. Okay, how much this particular x input, x1 input are sensitivity toward their y1 output. That's the particular thing we are talking about. Okay, so that's the basic thing that we can talk is like sensitivity. So this is the main important part we can capture on. So Jacobian matrix is all about sensitivity. So we take the function of xm like fm, which actually say that the how all the particular output that you are thinking about it. App x is say that all the particular input that you're talking about. And if you just want to just figure it out, the first order partial derivative, just if you want to know that how much this all input and output are sensitive to each other to find out the something. Okay, so the best way is the Jacobian matrix, and that is the basic importance we need in machine learning backpropagation. When we actually moving toward backward pass and forward pass, we need to actually calculate the gradient, and we need to adjust the gradient and weight and biases, all the particular stuff I don't know, but that particular one is helpful various. So it's deal with multivariable. So when we actually talking about partial derivative is all about take as one input and remaining all the particular input sides constant, and they derivate one particular. So reducing the computational cost, we actually use Jacobian matrix. They compute all the entire matrix dimension, high dimensional spaces over there in the short periods of that, like at the very fast, at parallelly process all the particular information. So that's the main point that I think it reduces the computational cost. Okay. Okay, so that's the Jacobian matrix is in helping the back propagation of machine learning and in the part of artificial intelligence neural network. So second one, direction and transformation. It give a direction and transformation, how much we need to adjust. Like if you know that sensitivity of each other, like X input and output, then it's give a direction where to this we need to shift this particular one to get that particular output. Okay, and it's help us to transform that particular variable according to it. So that's the basic thing talking about Jacobian matrix. And if I want to talk about Jacobian matrix, say Jacobian matrix is all about, now let's suppose this particular is graph where this particular data and this is like a particular figure. If you want to just make this particular figure as a circle, okay, Jacobian matrix helps us to do particular stuff. Let's suppose, let's try to again, this is a particular square, this 2 by 3 square, and if you want to just square much bigger, 4 by 4, then Jacobian matrix helps us to do particular stuff. They calculate the how much you need to change this particular square to become that particular area. So that's the basic important role of geometrical meaning of Jacobian matrix is like it helps us to stretch and squash the especially square and all the geometrical figure that you can consider. Okay, so that's the basic thing of Jacobian matrix. I think the important part of Jacobian matrix is basically it processes the matrix data it parallelly, it reduces the computational cost, and the more important part is like it helps us to know the sensitivity of all the possible outputs and multivariable outputs and multivariable inputs simultaneously without respectively it gives the information. So that's the important part of Jacobian matrix, and that's why I consider this is important part. And okay, why this particular one is important? I just consider this one is important because of that. When you actually try to use this particular concept in like machine learning, all this particular, you should to know about how actually Jacobian matrix work here, and so that's important one. Okay, again, if this one is going to productive for you, if you learn something from there, then it's my pleasure, and see you soon.